Let's talk about the energy of orbitals when there's more than one electron. Remember what we said when talking about the energy of orbitals in hydrogen. We said that the energy only depends, there's a constant over n squared. The energy of an orbital only depends on the number n, on the quantum number n. This is why we said that the energy of the 2s is equal to the energy of the 2p in hydrogen. However, as soon as we start putting more than one electron, as soon as we go away from hydrogen and we study helium, lithium, beryllium, you name it, um, this will change, as probably you may have learned before. So, what factors are going to have this equality broken when you have more than one electron? There are two main characteristics that we need to understand. The first characteristics is the so-called shielding. What is shielding? To understand this, please, you may want to go back to the previous slide that mentioned in a previous video about electrostatic interactions, how negative and positive charges attract. If you don't remember, you may stop the video now and try to go over this so that at least you have it refreshed. But I'll consider that as understood, and we will talk about what shielding is. Shielding is the capacity of neighboring electrons to shield the nuclear charge. So, in other words, let's say that because of the repulsion of these two electrons, this specific electron will feel less attraction to the nucleus because this one is kind of bothering, it's kind of repulsing. So the overall net result is less attraction, therefore less stable. If that electron is not there, this orbital is less shielded, if you will. Therefore, this electron feels more strongly the nuclear charge, and therefore it's more stable. A very related property to shielding is what we call the effective nuclear charge. In other words, what charge does the specific electron feels after the shielding? Because if if this charge is specifically +3, but there is some shielding because of the presence of these electrons screening the positive charge, the effective nuclear charge is what charge does this electron effectively feel? Well, it'll be something lower. It'll be something less positive, okay? And as we said, because there's more screening, there's more shielding, this orbital, this 2s, will be less stable, okay? To give you some more examples, if this electron is outside and these other two electrons are closer, the effective nuclear charge from this electron point of view is +1. Why? Because these other two electrons are kind of bothering. So the shielding will be more effective when the electrons are in inner shells. The same way, if that electron is closer, the shielding will be less effective, and therefore this electron now will experience the full +3 charge. Okay. So other things that we need to keep in mind regarding shielding is that additional electrons in the same orbital will increase the shielding a little bit, but the shielding will be even more important when the electrons are in inner orbitals. We will solve a problem specifying that, because I think this distinction is important. Alright, so this question is, what electron feels a stronger effective nuclear charge? The 1s in nitrogen, the 1s in oxygen, the 2p in nitrogen, or the 2p in oxygen? Well, you may want to just picture what does this look like. Very simplified. Here's your 1s. Well, it should be the whole thing. Again, this is all simplified. And here's the 2p and the 2p. Well, it's asking for which one will feel a stronger effective nuclear charge. Well, first of all, the closer to the nucleus, the less shielding there will be. So the 1s will have less shielding because these electrons in the 2s and the 2p will not be bothering, and therefore if there is less shielding, there is a larger effective nuclear charge. However, which one has more effective nuclear charge? The oxygen or the nitrogen? I'm sorry, I put 6. This should be nitrogen is 7 and oxygen is 8. So in this case, because the positive nuclear charge is higher in oxygen, the 1s of oxygen will be the electron feeling a stronger effective nuclear charge. Now, what this question asks is, which one will experience the largest shielding from other electrons? We said that the 1s will experience a lower shielding. The 2p, now we have to remember from previous courses that for nitrogen, the valence, well, it's 2s2, 2s2, 2p3, oxygen is 2s2, 2p4. Okay, which on the 2p, we already decided that the 1s will have small shielding. So it's either the 2p of nitrogen or the 2p of oxygen. Notice that in the 2p for oxygen, there is 4 electrons bothering each other, if you will, and in nitrogen there is 3 electrons bothering each other. There is more shielding when you have more electrons, therefore the oxygen, the 2p electrons in the oxygen will experience a larger shielding. Hopefully that makes some sense. We'll practice more.